The star Betelgeuse, an extraordinarily colossal red giant viewed in the constellation of Orion, has long dazzled stargazers and astronomers alike due to its sheer size and brilliance. If Betelgeuse were placed where our Sun is, it would expand beyond the orbit of Jupiter, highlighting its gigantic size. Despite being approximately 642 light-years from Earth, its immense size makes it one of the most awe-inspiring stars visible to the naked eye. In fact, Betelgeuse has exhibited odd behavior, such as dramatic dimming and brightening cycles, which many researchers believe signify the star nearing the end of its life. The renowned physicist Brian Cox recently made a significant statement that Betelgeuse is on the brink of a spectacular explosion expected to occur within the next 14 days. This event, known as a supernova, will mark the conclusion of Betelgeuse's life. However, it will provide an incredible opportunity for scientists to study one of the most mysterious and powerful phenomena in the universe. As a red supergiant, Betelgeuse is among the largest and most massive types of stars. It has been a focal point in astronomy for decades, but its recent eccentric changes in behavior have led to speculation that it is preparing for a massive explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a tremendous explosion that releases vast amounts of energy, radiation, and stellar material into space. Betelgeuse's impending explosion is predicted to be a Type II supernova, a specific kind of stellar event that occurs when the core of a massive star collapses. This collapse sets off the release of neutrinos and radiation, creating a shockwave that obliterates the star. The explosion will be so bright that it could be visible from Earth without telescopes, potentially outshining the moon in the night sky for weeks or months. While such an event would typically be devastating if it occurred close to Earth, Betelgeuse's distance of around 642 light-years ensures that, although the explosion will be dramatic and visible, it poses no threat to life on our planet. Instead, this event promises to reshape our understanding of supernovae and other cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will in its entire lifetime. Betelgeuse's explosion will not only be an extraordinary astronomical spectacle but also a pivotal moment for science. Experts are eager to observe this captivating event from its earliest stages using a combination of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the critical aspects of the supernova will be the burst of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can even reach Earth before the light from the explosion due to their ability to pass through nearly anything without being affected. Observatories like Japan's Supercameo and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's final moments. The explosion will also offer crucial insights into the creation of heavy elements. When stars explode, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is fundamental to understanding planetary development and the chemistry of the universe. While Betelgeuse's massive explosion is unlikely to have adverse effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the release of cosmic rays and charged particles, could lead to more intense auroras, expanding the areas where the northern and southern lights are visible. Though these powerful rays might temporarily impact satellite communications and certain technologies on Earth, the disruptions are expected to be minor and short-lived. Perhaps one of the most exciting aspects of Betelgeuse's explosion is its visibility to everyone on Earth, not just professional astronomers with advanced equipment. For a few months or even longer, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This event will captivate not only expert scientists but also amateur stargazers and the general public, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency to the matter. Observatories worldwide are preparing to monitor every phase of the cosmic explosion, and the data collected will be invaluable, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a rare opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the universe's scale. The event will also provide a unique opportunity to investigate dark matter and its influence on the structure of the universe. Dark matter, the mysterious substance that constitutes about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could offer indirect clues about dark matter's role in the cosmos. Betelgeuse's cosmic explosion will bring us closer to understanding the life cycles of stars, especially how massive stars contribute to the creation of elements essential for life. Supernovae are critical events responsible for spreading heavy elements throughout the universe, elements that eventually form planets, and ultimately life itself. As Betelgeuse's supernova unfolds, scientists will also have the opportunity to explore the relationship between massive stellar explosions and the evolution of galaxies. When stars like Betelgeuse explode, the energy and matter they release can trigger star formation in surrounding regions of their galaxy, creating new generations of stars and planetary systems. Understanding this process is crucial to uncovering how galaxies evolve and sustain life-friendly environments. Another fascinating aspect of Betelgeuse's imminent explosion is the potential for advances in astrophysical modeling. The data collected from the supernova will enable scientists to refine their understanding of how massive stars die. By comparing Betelgeuse's supernova to theoretical models, astronomers can improve predictions for future stellar deaths, especially those of other red supergiants nearing the end of their life cycles. Beyond the scientific community, Betelgeuse's explosion is likely to inspire a wave of public interest in space exploration. The event will be widely visible, offering everyone a chance to witness the dynamic nature of our universe. Schools, observatories, and science organizations worldwide are already preparing outreach programs to help the public understand and appreciate this once-in-a-lifetime celestial spectacle. Such programs will likely spark curiosity in the next generation of scientists and astronomers. Additionally, the study of Betelgeuse's supernova may have implications for future technologies. Supernovae release intense energy and radiation, which could inform the development of new energy systems or provide insights into managing cosmic radiation for long-term space exploration missions. As humanity continues to push toward interstellar exploration, understanding the impacts of supernovae on spacecraft and planetary systems will be increasingly important. Finally, Betelgeuse's supernova will serve as a reminder of the interconnectedness of cosmic events and life on Earth. The heavy elements produced in past stellar explosions are what make up the very fabric of our planet and our bodies. Witnessing the death of a massive star like Betelgeuse will offer a humbling perspective on our place in the universe, a powerful connection between the cosmos and human existence. While we await Betelgeuse's final act, scientists continue to monitor the star closely, gathering as much data as possible before the explosion occurs. Whether it happens in the next 2 weeks or the next few years, Betelgeuse's supernova promises to be one of the most awe-inspiring and scientifically valuable events of our time. Structure new stars, planets, and, surprisingly, living things. By concentrating on insect juice, researchers will acquire important insights into how these components are made and distributed. The social meaning of insect juice's influence is likewise significant. For a long time, people have looked to the stars for guidance, inspiration, and meaning. The vanishing of one of the most apparent stars in the Orion constellation will incite philosophical reflection on the transient nature of the universe. In certain cultures, such cosmic events have been interpreted as signs or omens of great change. Insect juice's explosion could evoke a combination of awe, fear, and wonder, as people from various walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, bringing more people into the quest for knowledge about the universe. Amateur stargazers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the cosmic explosion. This democratization of science will unite people across the globe, all watching and recording the same astronomical phenomenon from their unique vantage points. Betelgeuse's explosion isn't just a spectacular event but also a stepping stone for future research. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is critical as humanity looks to expand its presence in the solar system and beyond. Moreover, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are responsible for spreading the building blocks of life, such as carbon and oxygen, across the universe. By studying Betelgeuse's explosion, researchers can better understand how these building blocks spread to other planetary systems, potentially sparking life elsewhere in the universe. Betelgeuse's impending explosion is set to be one of the most significant cosmic events in recent memory. Its astronomical burst will provide a wealth of scientific data, enhance our understanding of the universe, and undoubtedly captivate people worldwide. Betelgeuse's death will mark the end of a giant star but also symbolize the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will anxiously watch the night sky, anticipating the moment when one of the universe's most powerful forces erupts into view. For scientists and stargazers alike, Betelgeuse's final journey will be awe-inspiring. As Betelgeuse approaches the last phase of its life, one of the more speculative but astonishing possibilities associated with its impending explosion is shedding light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one expected from Betelgeuse, could hold the key to unlocking some of these secrets. Supernovae release immense amounts of energy and radiation, and some researchers believe these powerful forces may interact with dark matter in observable ways. One intriguing hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the energy generated by Betelgeuse's cosmic explosion could provide clues about their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, a mysterious phenomenon that has puzzled scientists for decades. Additionally, there is potential for Betelgeuse's impact to offer insights into the nature of dark energy. Dark energy is the enigmatic force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the greatest challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's effect on stellar death, as supernovae are believed to be influenced by the universe's expansion. Observing how Betelgeuse's cosmic explosion propagates through space could offer vital data to help scientists understand how dark energy affects massive events and shapes the universe's large-scale structure. As Betelgeuse's massive explosion approaches, astronomers are preparing for one of the most anticipated cosmic events of the century. The impact will provide a unique opportunity to observe the final stages of a massive star, offering insights that could have implications far beyond our current understanding of stellar life cycles. While scientists anticipate the dramatic display of the cosmic explosion, they are also refining techniques to study the aftermath of such an event. One area of focus is the formation of a neutron star, or potentially a black hole in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova explosion. These compact objects, which can have a mass greater than the Sun compressed into a volume no larger than a city, are a key focus in astrophysics. If Betelgeuse forms a neutron star, it will provide a rare opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to produce incredibly strong magnetic fields and are sometimes observed as pulsars, emitting regular bursts of light. The formation of such a stellar remnant could offer valuable insights into the fundamental physics of extreme gravity and the behavior of matter at extraordinarily high densities. If Betelgeuse collapses into a black hole instead, It will mark another major breakthrough for scientists studying the formation of these enigmatic objects. Black holes, which are regions of space where gravity is so strong that not even light can escape, have been the subject of fascination and theoretical research for decades. Observing the formation of a black hole from a relatively nearby star like Betelgeuse will help scientists refine their models of black hole formation and better understand their role in the universe. Moreover, it could provide new ways to observe the event horizon, the boundary beyond which nothing, not even light, can escape, offering further insights into the nature of black holes. Another major consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, produced in events like supernovae, can travel vast distances across the universe. While some cosmic rays are detected by observatories on Earth, others have been challenging to study due to their elusive nature. When Betelgeuse explodes, its cosmic burst will release an enormous amount of high-energy particles, potentially allowing scientists to study cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium and what effects they might have on space travel and technological systems on Earth.